And we are recording and streaming with Mr. Ashton Forbes. I just now got the four orbs. Okay, Forbes.
Just now, yeah.
I'm a smart guy. I'm a smart man. You can't get past me. Nothing gets past me. Ashton's been on here several times before. And I first found out about you through just MH370 and seeing you on Alex Jones, and I still link that interview to people. It's fantastic. But kind of amongst other things, I saw you posting about the USO, the unidentified submerged objects. But from what I do understand about UFOs, as I am a UFO junkie, is underwater, outer space, air, it's all irrelevant in terms of when you're talking about these propulsion systems, manipulation of physics as we know it. It is underwater or in the you probably go through rock in the same way. So that's kind of not the focus of it, but rather I think what everyone likes and I think what you're most passionate about, if I can make that assumption, is the energy sources, what it implies for physics, and how ultimately it can be used to change it's not all weapon. I mean, nuclear weapons, sure, vaporize cities. You can also run cities on nothing. And that's, the double-edged sword of all of this stuff. And it really is it's not bullshit that like a radically reformed world. I mean, so much, I'll shut up, but so much is just based on energy. I mean, if you could desalinate ocean water, no kid, no one's ever thirsty again. If you could automate, farming and irrigation, you get rid of starvation. And humans are always going to be evil and kill each other, but so much could be alleviated. And I think that's the importance of it. So I'm going to post a live link. But Ashton, you take it away. Explain to me, or if you
Yeah.
want, what over unity is and how a caveman like me can understand.
Well, I think one of the biggest takeaways is that we are all cavemen, and I think we look at ourselves and we think that we're so advanced. But I think back to those Geico commercials where they'd have like the cavemen in
Yeah.
suits and what have you. And it's like that's what we really are, is
Yeah.
that we just think we're advanced, but we are still little children at the playground pretending, with respect to, if there is another civilization out there, how big it could be, how old it can be, much more advanced it can be than us. And I guess the first thing I would say is that you talked about USOs. There was a video I posted that looks like an orb of light underwater traveling very fast. Some people think it's a fish. Sure, think it's a fish if you want. I don't see any fins. I don't see any movement like a fish, but fine. The reason why I think it's important, where I've never posted that video before, is this idea of underwater submersible objects. If you are familiar with the UFO community, the zeitgeist over the last few years has been that these objects, these UFOs, are they can traverse through different mediums. So they can potentially traverse through air the same way they can traverse through water. And I think understanding how that's even possible is very important, related to their propulsion mechanisms and then the energy sources that they use. And really what we're talking about here is riding a gravity wave. And if you want to think of what is a gravity wave, one way to think about it is to realize that space is not empty. Space is not nothing to give in outer space. And this is where conventional physics gets it wrong. In fact, it's filled with 0 point fluctuations at the quantum level, the level below the level that we can perceive. And if you look at it like that, then you realize, well, what is gravity then? Gravity is actually when this ocean of energy that we're sitting on deviates. When it deviates, these waves are gravity waves that are being manipulated here. And this means that we can extract this energy that's all around us. It's so small that we can't see or comprehend it out there. A difference in the density in one area versus the other causes a pressure from one area to the other. This is gravity as we see it. So with these objects, when they're manipulating this, when they're removing this 0 point energy all around us, now they're not connected to the water. They're not connected to the air in the way that we would conventionally think. And this is why it doesn't matter what they go through, and they might actually be able to traverse directly through solid matter as well. This was one of the questions I asked Salvatore Paez, because he has this inertial mass reduction for a transmedium craft, or one of his patents that's been approved by the Navy. And he was very standoffish about the question of whether or not it can go through solid matter, because the implications are huge. But when you really think about it, the atoms in our body, most of it's empty space.
Yeah.
Most of it's really empty space. And this goes back to like the Heisenberg's uncertainty principle and Schrodinger when it comes to quantum mechanics. So Richard Feynman and John Archibald Wheeler were the first ones to propose this idea that we are in this energy, this sea of energy. and that the amount of energy that is a huge amount. Not, it's like 10 to the over 100, so like 100 zeros of energy. And conventional physics thinks it's like nothing, essentially. So this is the most important thing to understand. If you want to understand how free energy is possible, because people are going to come and say, well, you can't violate the first law of thermodynamics, which is that energy is neither created nor destroyed. And it's true. We're not creating energy out of nothing. We're just accessing this sea of energy that's out there all the time.
It's yeah, and people are like, well, that violates, X law or this law. It's like, no, no, no. Time and time again, we've found that our laws aren't nothing, you can't violate it. You don't have to say it violates the no, 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 no. The laws are what they are. We don't understand it. It's like, well, this violates the flat earth. And it's like, maybe it's not flat. I don't get it. He went over the horizon in a ship and then he came the other way. That violates. It's like we might be wrong. And so whatever happens is happening. So nothing is being violated. What's being violated is our preconceived notions about it. But then also, yeah, what you're saying about uh it's such a large amount of energy. It doesn't even require that much of an imagination. I mean, you just have to look at going from conventional TNT to atomic weapons. I mean, think about this talk was happening in like 1940. Like, no, something that I think the biggest bomb at the time was called the Grand Slam. It was just enormous, but it was just all conventional explosives. And yet someone somewhere was like, I think they said the amount of uranium that was actually transformed into an explosion because it was really inefficient was the weight of a dollar bill. So I mean, it's like it's sticky notes. I mean, someone somewhere in the 40s was like, if we can convert this to pure energy, we can vaporize a city. And someone was probably like, that's fucking retarded. But it did happen. So it doesn't even require that much of a leap of faith. We just have to go, we're just going to repeat it again. Why can't something that is to nuclear energy occur in the same way nuclear energy was to, say, TNT? So it does require a leap of faith, but it doesn't require a novel thing. We've already seen this concept of much smaller creating something much larger. Atomic level, atomic explosions. Why wouldn't it happen again? Why wouldn't you track again? Go down to quanta or subquanta and it would be just extrapolated upwards again.
Yeah, that's a great example right there, because throughout history we have seen times where technology would have been looked at as magic or
Yeah.
impossible. I mean, even just thinking back to cavemen with fire, like the first
Yeah.
person that was like, hey, I can, take this flint and stick it together, rub sticks together and create fire. I mean, maybe they got burned as a witch or whatever, or like,
Yeah.
even the Salem trials. The sun revolving around the earth versus the earth revolving around the sun. Just cell phones. I mean, if you try to explain cell phones to somebody who's riding around on a horse,
Yeah.
they're gonna think you're a demon or
Yeah.
whatever, right? Like,
Yeah.
so you got to look at it from that. And then with respect to the bomb, I think the nuclear bomb thing is the best possible example you can use, because you would say, I've got this, like you said, this amount of mass can cause a massive explosion because E equals mc squared. That's all you really need to understand, is that a tiny amount of mass times the speed of light squared can cause a huge explosion. And when you realize that, and back probably in even the 1940s, they would have said, you're crazy to think that that's possible. And
Yeah.
then we dropped the bomb and we realized that it is possible. Well, what if we also realized, even maybe during the Manhattan Project, that we don't even need this? We don't need
Mhm.
this at all. We can just straight up pull the energy from everywhere all around us, just like a vacuum, sucking it all up. And then we can cause an explosion of infinite possibility. I mean, Big Bang level or
Yeah.
produce a black hole level, because here's the
Yeah.
other thing. E equals mc squared. This means that energy is mass. And then here's another a mind bender for you, is that what if we can manipulate the speed of light itself? We think that the speed of light, E equals mc
C
squared, is
squared.
constant.
What
But
if
what
we
if we
jacked
can
it up?
shift it? What if we can slow it down or speed it up?
Well, if
Now,
it's
what does
C
that do
squared,
to the
jack it
effect of
up.
E equals mc squared, right?
Yeah.
So it can either increase it or reduce it. Now, this is important because if you reduce it, then potentially you have the ability where if I want to make a wormhole or a warp drive, the energy requirement is now much lower if my speed of light is slowed. And if I want to make an explosion and I increase my speed of light, now the energy level increase goes significantly up. So if you can manipulate what we think of as the constant, Now you can do something really amazing. And I think you can, because the 0 point energy around us is what's manipulating the speed of light. It's causing the permittivity of free space, which basically changes the refractive index of light as it comes through it. So the reason why we think the speed of light is constant is because we're in this medium everywhere. We can't get outside. We can't stick our head outside the fishbowl, so to
Mm.
speak. So it looks constant to us, but we know it's not, because we can already slow it down through other mediums. We just have to realize that what we think of as this constant is actually just it through our medium that we're in all the time. And then if you manipulate the medium by adding more energy to that area or removing the energy from that area, now you're manipulating the speed of light. So these concepts are very important to understand free energy, because free energy is the kind of thing where if you don't see the universe in that way, you can't comprehend where the energy is coming from. It's the most important part about this in order to change from what we've been incorrectly taught in the textbooks, that there's no energy out there, there's no way to extract the energy that's out there. When you think about it just logically and then look at the universe like this, you're like, oh, well, okay, this also explains where the Big Bang came from, where all the energy that's all around us came from everywhere
Mm.
and still continues to come from. So this is why I like discussing the whole aspect of free energy and over unity. And I want to talk more about the physics, and I want to talk about as well what I think what types of free energy devices have the most merit to them. It's not the situation where you just say, oh, this is going to work and this isn't going to work, but which avenues people should go down if they want to look into this more scientifically and from an engineering perspective.
Well, and another, just as an aside, another thing I always think of is like, all these technologies and all the like, yeah, again, nothing's being violated. So all this stuff exists at all times. And what have you ever seen those animations of like the inside of a cell, and it's like molecular biology and you see like the ribosome walking. I don't know if you've ever seen those. Like I think Harvard made some like 10 years ago, and it shows like the DNA helix unwinding and one thing I always think is like that was going on inside Ben Franklin's body when he was walking around. But like it's so hard to think about that. But in the same way, flight didn't exist then, but it did. It was allowed. The 747 you see could have easily flown over George Washington's Mount Vernon, property. He would have been like, what the fuck? But it's not like something new happened. We just found out something. Wi-Fi existed when Martin Luther was nailing the 99 Theses. It didn't exist because they didn't have any routers, but nothing changed. It's still allowable. So that is something that is like it all exists at all times. So whatever future like Star Trek warp drive shit is out there in our future, it is possible now. And that's the thing to remember. It's like we're not building new laws. It's not like a video game engine where it's like we've added more polygons. Like we're not adding anything new. And then to what you're saying about energy is yeah, when you look at like the difference between an atomic bomb and a hydrogen bomb, which is a hydrogen bomb, it's already 1,000 times larger. But a lot of them, the early ones were just like A bombs jacketed. I'm probably gonna get this wrong, but like jacketed in like deuterium or tritium, but it was just hydrogen. So you didn't even need well, you did to prime it, the plutonium or uranium. But when you start thinking about like deuterium or just hydrogen, and you're like, well, what H2O? You're like, so like the entire world's oceans. It's like, yeah, all of that. If any hydrogen or deuterium can be used and wrap the bomb and you can make it exponentially larger, that means all that energy does exist somewhere. We don't, to us, we're just like, yeah, it's water. If you can convert all the hydrogen in this to an H bomb, I mean, you'd vaporize the planet. Like, fuck Zarbomba. Like, you'd crack the planet. It's just water. The energy is not coming from anywhere. It still is in there, but it's just, I can look out at the Atlantic right now and it's like, oh, all of that could be, but it's not. So, whatever's out there, this ocean of energy, again, it's not something that's new or being ushered in. It already is there. It's just it takes the form of matter. So it yes, it's mind-blowing, and that's fine. You're allowed to be completely shocked and amazed by it and be skeptical. But all of the precedents are there for we've seen these kind of scale jumps before, and it would actually be more absurd if we thought it could never happen again.
Yeah, and it's funny that you mentioned the hydrogen bomb there, because Russian physicist Sakharov was the first person who proposed that 0 point energy might be able to explain gravity. And he worked on the hydrogen bomb with Russia. So, you look back, the physicists that people should be listening to would be people like him and people like Richard Feynman,
Uh-huh.
who was trying to tell people that the amount of energy in a coffee cup is enough to boil all the Earth's oceans.
Yeah.
Going to your analogy, like this, you're
Yeah.
like, why are we just ignoring these guys? Why do conventional physics just decide, no, ignore all that, just pretend like there's nothing there, that everything around us just came from nothing.
Yeah.
Even though Einstein himself is quoted as saying everything is energy and that's all there is
There is
to it,
to it. Yeah.
right? Like, and so, and hydrogen is potentially like the most basic form of energy. Like, if you think of energy
Yeah.
coming out of the ether, it's getting more and more complicated. And eventually it makes the jump out of the water and becomes photons that we see with our eyes. And then after that, what happens is it becomes hydrogen, potentially, as the very first basic element. And then the elements begin to combine, and then they form things like water and every other element, and they get more and more and more complicated. And so when you look at it like that, you think, oh, well, hydrogen actually makes sense to be the next bomb after atomic bomb as well, because instead we're like making it simpler and simpler. Like, what, we need less and less stuff. We don't even need, radioactive material anymore. That a hydrogen bomb is completely clean as well, is what
Mm.
I've read. And then after that, it's just straight up 0 point energy, which is the cleanest possible source of energy. Like, there's a lot of people out there that are concerned with uh, climate change and solar power and wind power. And it's funny because I was somebody that was big on it. I have a hybrid car that I drive around because mostly I don't want to pay as much for gas. But it's also neat that Tesla has become really huge. Solar panels have gotten really big. But the problem with this is that it's a huge amount of waste when we have to get rid of
Hmm.
those solar panels, or with the wind that's like killing birds. And then when they fall apart, like they're spewing toxic smoke into the air. So all of these mechanisms are inefficient compared to literally just vacuuming up the energy that's all around us all the time. And that's a question of, how do we interact with that energy, that sea of energy, to vacuum it up as we need to be able to just pull it straight out of the area that's all around us all the time. Um, there's been mainly, the one thing that people think about is magnets. But before I say that, what I want to say is I want to explain first the basic principle of energy itself. A lot of people, it's just like, where does energy even come from? When I turn my lights on, when I have this light going on here, where's this coming from? What's happening here? A lot of people don't even understand the concept. And it's not as simple as, well, that the electrons are just flowing through the wires and they're going from your power plant to your
Yeah.
light here.
That is
More
the upper
complicated than that.
that's the upper limit of my understanding. I was about to say it's electrons and wires, and that's all I
Yeah,
have.
and that's really what most people understand, but it gets a lot weirder than that very quickly. Especially the one video that I tell people to watch, which is funny because Salvatore Paya has mentioned this to me. He's never mentioned to like watch any YouTube videos or anything like that. He says there's this guy Veritasium. He does electrical engineering
Yeah,
and
yeah.
videos about it. There's one about how fast it would take when you turn on a light switch to turn the light on that's right next to you. It's like how electricity works. And the argument is, let's say I have a switch right in front of me. In fact, I'll use a couple props to make this a little bit easier for us. None of these props are like available or appropriate for videos. So I'll just use these quarters. So I've got this quarter here. This is my switch where I'm going to hit on or off. And this is my light that I've got over here. So what he's going to say is that if I extend a wire and it goes all the way off the screen for all the way around the earth and then comes back around and connects the long way, if the power flows through the wires, then the power should have to go at the speed of light through the wire from my starting point and then come out down this way. And so it should take the amount of time is whatever the length of the wire is. And so he flips on the switch, and you would think, okay, it should take 1 second for the electricity, the light to flow through, the energy to flow through the wires at the distance that we've got it set up at, based on the speed of light. But no, it doesn't. The light switch turns on immediately, which implies that what's happening is the energy is flowing directly from point A. Oh, God. Should use a better prop. Point A to point B, directly this direction, as opposed to all the way up and around. So what's happening is that the electrons are creating fields, electromagnetic fields, and the energy is flowing through those fields based on the right-hand rule in physics. And the energy is then essentially flowing directly from the power source, the battery or whatever it is, to the light itself. It's the same reason why Well, actually, so that's what I want to lay out there first. And there was a lot of people who tried to debunk it and say, no, this isn't possible because it would violate causality and all this other stuff. They're all wrong. He did a second follow-up video where he actually scales down the experiment and shows that yes, the energy is flowing that way. And then when it, after a second, then it's like fully lit. But before that, there's still energy that's reaching the bulb, which is pretty mind blowing, if you ask me, because then it begs the question of where's the energy really coming from? If it's not really going through the wires, it's actually it must be going through the medium that we're
Yeah.
in all the time here. And then the other concept to understand is Tom Bearden. Tom Bearden, this guy's a legend. I don't know if I mentioned before on your previous podcasts, but Lieutenant Colonel Tom Bearden, he was in Black Projects.
I've watched interviews of him.
Yeah, he's big supporter of Tesla and Tesla's work, of the Ehrenhoff-Bohm effect. He reviewed a lot of free energy devices for people that they just disappeared or had a heart attack or whatever. And the thing that he says is really important is that all the coal, all the oil that we've burnt, all the even nuclear power, solar power, all the wind, these have never added 1 watt to the power lines ever. That's not where the energy is coming from when we burn it. And if people are going, wait, no, you're lying, Ash. And I would say, look at how nuclear power works. We're not splitting atoms and extracting the energy. That's not what's happening at all. We take the very hot cores and we put them into water and we have them create steam from the water.
Literally,
And
all
then
of
the
human
steam,
civilization is just more efficient ways to make tea. I think it's not my quote. I've read that before, but it's just
no, that's great
increasingly
because that's what it
sage
is.
ways to like
We're
fucking make coffee.
we're just making tea. We're creating steam, and then the steam is spinning a generator, just like if you were
Yeah,
going to hand crank a
yeah,
generator. You're like, wait, that's how we're doing it? That's the most efficient way? It's like a 3-step process of conversion of energy to get
yeah.
to what we need. That can't be the most efficient. That's what we think of as like the most efficient. You're like,
That's like the
oh my
cutting edge
God.
shit on aircraft carriers, the linchpin of the U.S. Navy. What is it? We're making tea. Like,
It's
really? Yeah, no, yeah, no.
so then what really is, where is the energy really coming from then?
Yeah.
So then the answer is Tom Beer would say, keep your dipole open. So what's a dipole? People would say the simplest comparison is a battery. Positive up here, negative down here. What's happening in the battery? There's more negative electron density in the bottom than the top. You connect a wire to it and the electrons begin to flow and the energy begins to radiate the same way I described before from the battery to the source or to the light. And as long as that asymmetry exists, more electrons down here than up here, then currents flowing, power is being generated. It's really that simple. That's all it is. Whether or not that's a battery or capacitor, same kind of concept, storing the energy, so to speak. That's all we're doing all the time. So then the question is, okay, well, if that's all we need is just to have our dipole stay open, to have this asymmetry of positive and negative charge, and then energy will flow. Why are we doing it this roundabout way where we're constantly cranking a generator? Now let's convert that to a pendulum where you can take the same concept of your frequency and convert it to a pendulum, like a swing, for example. Now, when I'm pushing a swing, I don't know about you, but I don't constantly push on the swing the whole time.
Yeah.
That's silly. Why would I do that?
You just keep it.
I just when the swing comes back, I push it again, right? At a
Yeah.
resonance, right? You could literally step your clock to it like
Yeah.
1 second, 1 second, 1 second. It's like, so why don't we convert that theory or that concept over to keeping our dipole open with our battery with energy? Why don't we do that? Doesn't that make a lot more sense? And in fact, what if the math of an RLC circuit, which is an inductor, resistor, and a capacitor, what if the math actually said that when you do that, not only does the swing go back to where it was before, but it actually begins to do this.
Mm.
So this is parametric resonance in an electrical oscillator. You can actually do that. You can calculate the right frequency and you can calculate the resistance level. And if you are below a certain resistance level, then your swing starts to actually gain energy. So it turns out in an electrical circuit, it gets even weirder than if you're just on a swing where you would just expect the swing to always go back. If you push it at the exact right time, it gets bigger and bigger and bigger. And if the resistance is too high, then it doesn't work. The resistance is too high, then what happens to your swing, or your swing starts up here and then starts to slow down. So really the thing that really matters is what's the resistance. Because when the resistance is lower, you get to the point where your parametric oscillations increase bigger and bigger and bigger, more and more and more energy. It's coming out of where? I would say it's coming out of that energy density, that energy that's all around us. So then you say, well, what's the answer to reducing the resistance, right? Because if I get my resistance lower, then that energy is going to go crazy. In fact, if I get my resistance to zero, then like I imagine like right away, like energy is just instantly huge amounts of energy that are coming out of where? And this is where I think probably people get stuck in that conventional view where they think there's nothing to give. So this just I can't take it to its logical extreme where it's like, well, I just reduce the resistance, hit the right frequency, and now we are just swings going wild. This is the basic concept of free energy. And then you can see if this is true, not only can we get free energy that's out there to be extracted, where whether or not you want to explain where it comes from, if you have a better explanation, go for it. But we can actually modulate that. Like, how much do I want to pull out?
Yeah.
Because I don't need this huge amount of energy. I just want to power this light, my computer that's got going on, this camera, this other light over
Yeah.
here. And this is the other thing that people don't realize that I want to say, and then I want to get your feedback is a lot of people don't understand what uses energy up in their household either. The number one thing
Air
is going to be your air
conditioner.
conditioner.
Yeah.
Like it uses the vast, vast
Yeah.
amount. And people don't think like, oh, okay, maybe the air conditioner is like a 10. And let's say that this light is like an 8 or a 9. No, no.
No, it's
The,
like
the
a
light is like
10 and like a
1/1000th of the
yeah.
amount of energy
Yeah.
as the air conditioner is. And your refrigerator is probably the next thing. So if you want something that's
Yeah.
power efficient, you want to have your refrigerator be very power efficient. You don't want it to have to use energy very much. But anyway, why is this important? Because we can by far extract more energy out of the environment than what we need. Again, it's like we need almost nothing, even with the air conditioner. Like the amount of energy that we're using is nothing. Because some people may say, well, if you take this also to its logical extreme, like, are you afraid of us extracting too much energy out of this sea? Like, what's the bottom to it? Is there a limit
Mm.
that's out there as well? And I would say there probably is a limit. And the limit is also related to the propulsion concepts, which is if you pull too much energy out, what are you doing? Are you creating a black hole? Are you creating a void or a singularity in space time at that point?
Mm.
And maybe you are. Maybe that's literally what a wormhole is that you're just pulling so much energy out that everything in that location goes from one spot to somewhere else. So just some, what are your thoughts on some of those concepts or what questions do you have as a guy who, hasn't
Uh,
dug too much into the physics?
yeah, I was gonna say, um, I don't think it needs to be too deeply, I guess, explained in the same idea that, I mean, and again, I've had Richard Rhodes on here who wrote the definitive book, Making the Atomic Bomb, and then the follow-up Dark Sun about the hydrogen bomb. And I think somewhere in it, he's said the amount of energy that, I don't know, like 100 train cars full of coal arriving at a power plant every day, 365 days. All of the entire year is equal to like half of a train car of like unenriched uranium one time per year. So like one train car per year, as opposed to an entire train, 100 cars long every day, one like half full, not even enriched. And then to go one step further, and the same amount of energy in that scarcely filled train car of unenriched uranium is the same as like a couple milliliters of deuterium of seawater convert. And it's so that alone you kind of don't need to. So just with that, you go, oh, so that's an H bomb. Well, this is probably like a decent amount of the H bombs. The shower I take will probably be the world's nuclear arsenal. Okay. But then let's say that's not enough and we have to explain it even further. We also don't know what's outside the observable universe. So, like, if I had a solar panel outside my apartment and I got a huge TV back there, I got a gaming PC, I got all this podcast shit, you might be like, where's the energy coming from? But if you only knew my apartment, which is like 1,000 square feet, and you didn't know about the planet, you'd walk outside and be like, as far as the eye can see, those are mountains and you'd be like, oh, this apartment is so small compared to the volume of the planet. So you'd be like, there's no violation of anything. It's just we're sucking it all. It's like nuclear submarines using the ocean as a heat sink. It's like it's so just beyond it. It's like, yeah, it's a blank check. Why can't that happen again? So what if the observable universe is whatever 14.3, or I guess it would be 13 point, whatever it'd be that
No,
double.
they've doubled it.
Yeah, yeah, yeah. Whatever whatever
Your
this,
information's out of date. It keeps getting older
damn
and
it,
older, by the way.
misinformation. Let's say it's 100 trillion light years wide, whatever. That's still just okay. That's a circle or a sphere. We don't know what's outside of that. So we might be pulling energy from the equivalent of, you open up the tap water and you get a little, it's like, where's that coming from? It's coming from the ocean. It's so just beyond, it's just such a big blank check. It's a trust fund bank account. Yeah, just swipe the card. I don't know where it comes from. It could just be that. So even if which I don't even think we need, I think just the whole idea of like, yeah, I mean, convert hydrogen, but it might be that nothing's being violated at all. It's just we're sucking it from, I mean, how small is I don't know, like the nucleus of a cell compared to the rest of the cell, or like a baby surrounded by amniotic fluid. Like it's growing in a much larger soil.
Yeah.
Our universe might just be part of like this insanely vast, on a 100 quintillion raised to the quintillion light years in diameter sphere of an ocean of energy, and we're just this little nuclear submarine in the ocean using the ocean as a heat sink.
Yeah,
So
I mean,
yeah, it could just be from somewhere that we don't see.
yeah, and
That
that's where
makes
I think even
sense.
like 10 to the 100 zeros might even be small too, because it's just kind of more based on what our observable reality
It
is.
might be that
We,
raised to 10 to the 100. I mean, it might be so gone off the
because even if you take
scale.
this small amount, you multiply it by all the distance that we see in the universe and you add it up and you realize very quickly you're getting to an infinite amount of energy essentially that's out there. And it's also important, I think, then to understand how that is connected. I would argue that all energy that we use around us is coming from that source all the time.
Yeah.
And even with like a magnet being stuck to the fridge, the energy that's causing that magnet to be stuck to the fridge is constantly refreshing itself. Like imagine like a computer program that's running or like a video game
Yeah.
that's constantly refreshing, it's constantly rendering
60
all the time.
FPS. Yeah.
If you look at it like that, then it's a much different way to look at the universe. But it's not incorrect. It doesn't change any of the math or any of the equations or anything like that, especially with respect to general relativity. And you start to realize, oh, well, the universe is electric then, right? It works the same way because it's connected directly to energy. And that the energy that's being refreshed out there, we can manipulate that. We can add to it, we can remove it. I'm more afraid of a black hole than I am of a nuclear bomb. And there's two ways to look at it. I think you can either look at it as an exothermic event, which is a release of energy, like a nuclear bomb is with our, mushroom clouds. And then the opposite would be a black hole, which is an endothermic event. It's a cooling process. It's an
Mm.
absorption of the energy that's around us. The shapes might look somewhat similar because all shapes in nature kind of do with that respect. But your endothermic event is an absorption of all that energy. Where's that energy going? What's happening with respect to that? You might even find a situation where it's like a horseshoe effect, where it's like you go around and you kind of meet back up at the same kind of point where both of
Mm.
them are just total annihilation in
Mm.
either respect. Like if we even made, people used to be concerned about CERN making a black hole. I used to think like, no, that's kind of silly. I mean, the energy, it's even at the small scales they are doing it. It's not, energy level is not high enough. That's what, if you read all the debunks of it, and that's what I used to think as well. But once you realize now, like the parametric oscillation, like once you
Yeah.
realize they like, oh, if we can harness that, if we can get to zero resistance, now I'm actually afraid of black hole formation again. And let me make it even more scary for you. I think we can do it with lasers that we've already figured out, like attosecond lasers that won the
Yeah.
Nobel Prize last year. Like it's really a matter of having your beams perfectly focused onto the right point and having the beams be high enough amounts of energy. And so it's like, what is an attosecond laser basically? Very high frequency, very high energy level laser. You're like,
Uh,
wow, okay. So now if I can do this, like I'm more afraid of people taking some of those high end lasers that they got at like private military contractors that are tens of millions than I am of like the Large Hadron Collider.
yeah.
It's like this thing is basically like a circus. It's just for the show. It's not
Yeah.
like for serious scientists who are that are thinking like really how can we break this system. And then I mean if you can make a black hole, that's game over for everybody.
Yeah.
Like that's game over
'Cause
for maybe our whole solar system. maybe even parts of the galaxy. In fact, I think when I
Maybe
realized that
that's sorry. Maybe that's the answer to the Fermi paradox.
that's
Where is
literally what I was
everyone?
about to
Maybe
say.
we're looking out and we're going, those are graves. As when you look at it like
Yes.
Arlington and you see all the cemeteries or all the gravestones, you might be like, oh, oh shit.
I
It might
love that
be,
you came to that conclusion
yeah.
because like that's literally my conclusion too. I'm like, oh shit,
Oh
because they don't.
fuck.
You know, they don't know how some of the smaller black holes have formed
Oh god.
because they're like, it doesn't make. They don't have any like
They don't have
model
enough
for that
mass
makes any
to.
sense for a small black. For large ones, they're like, okay, this makes sense. It was like primordial black holes from the early days, and then the smaller ones, they're like, yeah, we don't know how they formed that.
Where is
Like,
everyone?
where is everyone?
A bunch of
Why is it silent out there when we look out there?
you see all
Like,
the cop cars out there and you see a bunch of like white sheets and you're like, oh, those are bodies. Oh fuck.
well, that's
Oh
scary
man,
because think
that's
of the
dark.
implications for our civilization if that's the case, right? Like,
Ooh.
if that was true and you're in the government,
Huh.
I mean,
Huh.
I'll just tell you if that's true and I'm in the government, I'm like, we have to cover this shit
You have
up.
to
We
cover this shit
cannot
up
tell people.
immediately.
We cannot tell people about this. It's
Um,
too mind blowing, right?
yeah. I was gonna say the Attosec, just as an aside, it's like an MK Ultra trigger word. I vividly remember I was like 17 and I was just, as my buddy CJ used to say, higher than giraffe pussy. I was like, it's like the first time I ever ate an edible. And I was just sitting there at my buddy Joey's house. I don't know why. I was in the driveway on a lawn chair reading like popular mechanics, and they were describing what an attosecond was. And I just couldn't handle it. It was like an attosecond is to a second, what a second is to 300 million years. So just I don't think I've heard that word in like 18 years. So you just said attosecond, triggering word, like oh my god. But yeah, it might be my buddy we call him Reverend. We were talking the other night, and he was like, "We," and it's I think you agree, and most people agree. I hate the idea of like they're the benevolent leaders who have to decide what is right, and that's all fucked. But it might actually be right, where they might be using it to get us to a different planet or star system, because it's like it's like hitting the A bomb. It's like, yeah, we gotta go like 5 miles away and get in a bunker. We don't know what's gonna happen. It might be, hey, we maybe need to get to another planet first. Because this isn't an H bomb where you can get 100 miles away. If a black hole goes off, that might be game over. And we have reason to believe that that's what all those black holes are. So, and I hate that. I just hate the idea of like a patriarchal master has to tell us what's right. But that doesn't necessarily mean that that's not the case here, where they're going like, yeah, we don't know what's going to happen. I mean, and who's to say that that's not some crazy fundamentalist, group that thinks that they're bringing about the end times, and as it was written, I will bring the black hole. Like we have no idea if that's the case. So in this sense, they might actually be right to be like, hey, get another, we have to get another civilization on Proxima Centauri before we, press the button,
No,
right?
you nailed it, man. That's
Fuck.
what they're afraid of. I'm almost sure. Now apply what you just concluded for yourself. I didn't tell you to think any of
Mhm.
that, but I think that's what everybody should be thinking about when you look at it like this. Look at how these UFO disclosure advocates talk about this stuff now. Realize that they dance around everything related to the implications of the technology, everything related to 0 point energy. They dance around it. They don't talk about it. Instead, they all talk about aliens, telepathy, how many different species of aliens there are, if they're benevolent or malevolent. It's like, I'm not even concerned about that if it turns out we can just create a black hole, because it's just kind of game over at that point, right?
Yeah.
And you realize like that's the part that would be classified. So if these people are any type of people that have NDAs or they have contacts that are in the government that are, let's say, managing their perceptions, they are not going to be able to talk about the technology, the implications of it. They're not going to be able to talk about our surveillance systems in terms of what we're seeing out there that would show us this technology exists. They can't talk about any of that, and they don't. None of them do. None of them ever do. They always are talking about aliens and what have you. Although recently, this has started to flip. Specifically, Lou Elizondo was on Joe Rogan and he was on Glenn Beck. And this guy is former ATIP, meaning he was in the UFO investigator program or whatever.
Hmm.
And next thing I know, he's explaining warp drive to Glenn Beck. And I'm going, whoa, I was just on with Glenn Beck and I was explaining the 0 point energy concepts. I was explaining warp drive. And then Glenn Beck's like, is that kind of like a wormhole? And he goes, yeah, yeah. And I'm like, okay. I just told Glenn Beck this. So the next thing Glenn Beck asks is, have you seen the MH370 videos? Asks him that. And he gets real standoffish. All of a sudden, his demeanor changes entirely. And he goes, well, I'm not a conspiracy theory guy. And you're like, wait, but you think that the US government's hiding aliens from us, but you're not a conspiracy theory guy? Right. And then he says also, well, some people have told me it's fake and some people have told me it's real. And some of the people are saying, no, that looks like what it would look like, blah, blah, blah. And I'm just going, wow, like it really feels like he's trying to cover up for this
Mm,
0 point energy that's out there because he's a patriotic American. You know, he doesn't want, if we can make a bomb, a weapon like that, like you said,
yeah.
one fundamentalist that's trying to like jihad the world. I'm going to be
The
the chosen
harbinger
one to
of
destroy the entire
apocalypse.
planet.
Yeah.
Like, because now we're at the situation where if there's that much energy, where we don't even need this little amount of energy, we need nothing. Just anybody with the right equipment in their garage could just press the button, and then we didn't get the opportunity to get far enough away to Zeta Reticuli or wherever we got to go to be far enough outside the range of the weapon, you know? And these are the big
What?
implications because when you piece that together, and this science is supported by many, many scientific papers that support it, I just don't know how people have ignored it. You start to realize that, like, maybe this does explain this weird phenomenon of UFOs that's going out there and why we've been covering it up. Free energy.
I won't go into because I can go off on a tangent for a million. I just hate when people say I'm not a conspiracy theorist. Just it's called critical thinking. It's the same initials. See, just it's I just hate I'm not a conspiracy. I hate it. I hate it so much. But I was just thinking like, well, if anyone could do this, how come someone hasn't blown up the universe yet? And it might be like, well, those are what the black holes are. Just like it takes a supernova, like that star blew up a million years ago, and we're still not seeing it. It's because it takes time. I mean, if a black hole, we know black holes can be so strong that even light can't escape. So we might be looking out and be like, well, those black holes are billions of light years away, so they're not going to reach us for a while. What if it's pulling the light away from us? What if the black hole is actually like 100 times closer? It's like expanding. Like, what if a black hole is the size of like the moon in the night sky, but because it's sucking light away, unlike a supernova where you go, yeah, that blew up 1,000 years ago and it's still coming at us. What if a black hole was, it's like an inverse Doppler effect. It'd be like an ambulance that still sounded like it was a mile away, even though it was 10 feet away. So like what if black holes actually are just like like scaled correctly? What if the entire night sky is like black holes expanding, but because they themselves pull light away, we go, yeah, that's in the middle of Andromeda. That's 2 billion light years away. It's like that might be like 3 light years away or something. Like,
No, it actually, so here's the thing about it. So you have to realize too that it may be that distance itself is just an illusion,
uh,
and all there is time. And time dilation shows something really fundamentally kind of unsettling about our universe, which is that we can actually change the dial of how fast our time flows. So we can either move really, really slowly or very quickly. But for the observer, for us, it will just look like time is moving at a constant rate. We simply don't feel the time dilation effect from our own frame of reference, as Einstein would have put it.
hmm.
But from the outside perspective, if they're at a different dial setting than us, one person is than another, it's going to look like one of the two people is going to look like they're moving in slow motion, and the other one they're going to look like they're moving like Quicksilver. In fact, they could theoretically move so fast that they look like they're there 1 second and then they're not there anymore, and now they're just over here instantly. Um, and this is where you'd say, well, then it doesn't even matter if we are already being sucked up by a black hole. In fact, you could say that maybe is what's going on, because end of the day, our perception of time is simply an illusion based on our biology and based on the fact that we're all on the same exact planet that has the same exact mass. But when you start manipulating the energy densities, and mass is energy as well. So when you look at something like the Earth, this is just a massive, dense ball of energy. You're manipulating the gravity, and you're also manipulating the time dilation. You're changing the dial on your time. So this is where things start to get really weird when you really want to dig into the woo with it. But these things are all connected to free energy. They're actually, you cannot separate them because they're all based on the exact same physics principle that we talked about at the beginning, that free space is not empty. that there's this huge energy level. Because again, if you manipulate this density, you're creating gravity waves, because all gravity is an induced effect based on the amount of energy density from the 0 point fluctuations that are out there. And if I pull this away, now I'm dipping into that energy. I'm going to have a cooling effect because I'm pulling entropy out of the system, and I'm using that energy. That's becoming real energy. It's getting more complicated. It's coming out of our system. And now we have photons coming out of it that we can use. In fact, this is how all energy is coming out. And then it's just a matter of, well, how much energy do I want to dip and I want to take? And if I pull out the most, all of it, maybe that's a wormhole right there. So the less energy there is, there's less inertia we feel. Inertia is what gives us mass. So, and weight, I guess, is probably what I want to say. So if we reduce all these 0 point fluctuations, you're going to be in a situation now where we've extracted the energy. It's going to cool down in that area, and there's not going to be any inertia, no resistance when somebody moves, which is essentially what gravity is. So there's this connection between gravity, there's this connection between the inertia that you feel, and when you remove the 0 point fluctuations, no inertia. So if I were to go into outer space, I'm not going to move perfectly freely. There's still some resistance. That's the 0 point fluctuations that I'm moving through, their inertia. So if I remove that entirely, now I've got that free energy, reducive inertia, cooling effect, etc. When you look into free energy devices, the ones that actually have merit, that are like major companies like Kepler Aerospace has this MEC, which is this free energy device, or over unity is just another term for it. It's pulling the energy out. It has a weight reduction effect on the apparatus, and it's cooling down as well. The ambient air in the area around it cools down. And I actually showed a video on both my live stream and on my Twitter where you can actually watch John Searle's device, which is very similar to the MEC. You can actually watch it cool down. They have a thermal temperature scanner on it, and it gets so cold that the middle, you can actually, it has frost on it. You can rub your finger on it. You can pull the
Holy
frost off of it.
shit.
After watching an engine spin around where you'd think it should be heating up, but
Yeah.
it does the opposite.
Holy shit. Actually, I'm gonna have you share that. Hey, one second. Take the show over. I got pissed
Yeah,
off.
so
Hold on, take over.
so if you find a device that has those three concepts, that it is producing coefficient of performance greater than 1, that there's a weight reduction effect from the lack of inertia, from pulling the 0 point energy out, as well as generating the energy, or sorry, cooling down, I think was the last one that I was going to say. Then those are the ones you want to look into the most, and those are probably scaled up to a point where they're pulling enough energy out of this ocean that's having those effects are measurable and not very small effects. But again, like I said earlier, like if all we're trying to do is turn on the lights in our place, like that takes practically nothing to be able to. So it's so little amount of energy that's required to do that. And then it just becomes a question of, like with the parametric oscillations, like how much can you scale this up to pull as much energy as you want from around you? So there's a couple different ways where I think that they have merit based on understanding this physics and this science. One of them is plasma research. I posted a video on my YouTube showing plasma in outer space with no gravity. And it's interesting because you see these self-organizing properties where it forms this lattice structure to it, where you would think that if it's all just random, then you would have just random shapes forming, but it actually begins to form coherent shapes with like little tentacles off of it, basically. And so it shows that we're seeing these both attractive forces and these repulsive forces, and the way that the geometry of space-time works out is that they begin to form shapes that are familiar to us. In the video as well that I showed related to plasma, not only does it show the coherent shapes, but it also shows a double helix formation beginning to form. But the coolest part about it, even though you would say, well, double helix is related to DNA, so that begs the question, like, is plasma an explanation for how, or is gravity, plasma, some combination explanation for DNA? But it also shows galaxy formation. Some of the shapes that it begins to form are consistent with the rotation of what we see when we look at like the Milky Way and other galaxies that are out there. And this is important because we had to invent something called dark matter in order to explain why the stars on the edge of the galaxy were moving as fast as they're moving. Because we would
It
expect
doesn't check
otherwise
out.
they should
Just
be moving a
yeah.
lot slower, right? And so instead we say, well, there's this must be this dark matter that's out there that's causing it to speed up somehow. But then you look at the plasma and you go, oh, wait, no, it's not. It's not that. It's plasma. What's special about plasma? Plasma actually is the fourth state of matter, and electrons begin to just break free in a plasma. And now that we learned that all we're trying to do for free energy is create a dipole, more electrons down here than there are up here in asymmetry, you realize, if in plasmas electrons just begin to behave really differently than all the other forms of matter, that's a good candidate for how we're going to create an asymmetry that's constant. And it turns out all you really have to do is you have to put a different electrical charge in one part of the plasma, let's say up here, than down here. And the moment that electrical charge is in there, now you're going to create this asymmetry. And the plasma begins to self-organize as well, according to Ken Shoulder's exotic vacuum objects research. He actually called it exotic vacuum objects, even though there's like balls of energy, because he believed that they were pulling energy out of the vacuum. Now that we understand what energy out of the vacuum is in our sea of ocean, you're going, oh, he understood that there's this energy that's out there. And when we're doing this with plasma, we're just pulling the energy directly out of, I would call it the ether. Some people are going to call it the quantum foam. You're going to hear people call them the virtual particles. All of these are really just same concepts as to what people like Tesla and Maxwell knew over 100 years ago, that there's an ether of energy. We don't see it as purple mist or whatever because it's at an extra dimension, meaning like it's too small for us to even perceive, but it's always out there all the time.
Did you
Pretty wild.
did you show the video when I went to the restroom? Or are you talking about the one on
You want to
Twitter?
see the plasma one?
Yeah, I want well, I want to see the one of the thing cooling down at the center.
Oh,
Uh,
you want to see that one
uh,
too? Yeah.
yeah,
I'll have to
which
search
yeah.
for that one because that one was a while back, but
No,
let
you're
me
good.
show the plasma one while I'm doing that because the plasma one, man, like should get more views.
I
This
think
one blows my mind when I'm watching this. Let me
I
see.
think I gave you share capability.
Yeah, I'm trying to figure out
No,
which of
you're
these.
no
Oh,
no
this.
no no you're good. Yeah, no,
Yeah.
it's just wild the idea of it, yeah, sucking in or just becoming colder. It's like the antithesis of all logic.
Yeah, I
Whoa.
mean, this is wild. So this is plasma and zero G's forming a lattice structure right here. I'm just going to mute this actually. I just added some music to it because it's actually
Yeah.
in Russian, so they have subtitles. But you can see also these like tentacle things that are forming off of it. It almost looks like what you would imagine the shape of the universe to look like.
Yeah.
And then you see some of the movements of them where you see these organized movements. It's not just random
Yeah.
movement, right? And so it's like you look at it from this level and like this is like the
It looks like
smallest
it looks like when
scales
you
we can
see a
see.
jet go through a cloud and it
Yeah.
creates the
And this guy explains too that it's based on electrical charges and that basically, oh, there's a difference between the Coulomb force forcing things together and then the repulsive force that's separating them. And look at these like coherent shapes that you see there. But this part,
whoa.
they begin to form a void that looks a lot like a black hole.
Oh
Look at that.
God. Oh whoa.
How weird is that? Like, why is it doing that?
Whoa. Yeah. What the
And so they sent this information back to the scientists on Earth and they couldn't believe what they were seeing. I mean, they're just like, how do we explain this? You know, like,
these look like stills from like the montage of a movie where it's like
yeah.
in the 60s DARPA started pushing the boundaries without the president's approval. This looks like
Yeah.
it looks like shots from a movie like
I mean, this looks like a galaxy. That
yeah.
looks exactly like a
I
galaxy.
mean,
So there's your dark matter. Like, why do we
yeah.
need dark matter if we look at that video and you're like, look at this looks just like when we
Dude.
look at galaxies in outer space, this is exactly what they look like. This can explain their movement. And so then you're like, okay, well, now I've just connected dark matter and galaxy formation to plasmas, which are connected to electricity and energy asymmetries in the charges. And look at this. This is plasma organizing into a double helix.
What the
I
dude.
mean, now I'm like, if anyone tells me the universe isn't based on electricity and plasma, I'm like,
That
what are you talking about? Like, have you seen plasma in zero gravity? Like, this looks identical. Like
These
it's
are
not
the
just a coincidence that it happens to look like that,
these are
right?
the thoughts in the mind's eye as like the acid's hitting. You're just like everything's unlocking in front of you, and you're like, "Gee, it all makes sense now."
No,
That's
it really is. And I try not to dig too much into it because you can ask a lot of big questions.
sure.
Like, is this connected to consciousness and life itself? And,
Sure.
where do our beings come
Yeah.
from? And are we coming from this energy
Yeah,
source?
well,
And
you're never gonna get an answer from that. You can't. It's you can't never. That'll go forever. I'm more curious just about like I mean, perhaps selfishly, how can this affect my life? My life's fine. I'm knock on wood. I'm healthy. Everything's fine. But I mean, the history of mankind is suffering and scarcity. And at the risk of sounding like some kumbaya, no, but I mean, they're really in the same way like 100 years ago they could look forward and be like, the future's perfect. They're, 1/100th of the number of kids die at, birth, or, and, no one's getting whatever tuberculosis. And we would say the world's still so fucked up. But in comparison to 1924, we'd be like, it's unimaginably better. There is something about it's not going to solve everything. There's always going to be problems. But this is important because you want 2124 to be as alien to us as we are to 1924. You'd want to look back and be like, oh, they use child laborers. There's horses shitting in the street. Like, we still have murder. We still have rape. We still have, injustice. I get it. But it's not out of the realm of possibility to usher in a much better world. And then in 2124, they will have something as alien to them as zero point energy is to us. And that's the progression of society. But
well, what
that's where
if we
I'm
can't
interested
harness
in.
that level of energy unless, like, this is one thing that creeped me out when I watched John Thiel or Peter Thiel on Joe Rogan, is that he starts talking about warp drives first of all, and I'm like, okay, what? And then he says, like, what if an alien race has so much power that the only way to contain that power and prevent them from destroying themselves, remember the Fermi paradox, is that they have to either be completely altruistic, like totally benevolent, or totally malevolent, where like you have to have complete like fascist
Apex
control over
control.
it. And you start to think about like the
Yeah, no.
WEF and some of this stuff and like how they're trying to like this idea of a one world government. And you're like, shit, what if they know that like they have to either have perfect control to make sure that nobody's going to go out and pull off they're going to
The
create a religion
fundamental,
about
yeah.
being the one to cause the black hole or whatever, or if we have to be just completely like altruistic. What if they decide like there's no chance we'll ever be
They'd be
completely altruistic?
altruistic.
Because like you just pointed it out, right? There's always like war, there's always
There's
like
always going to be
horrible things that
someone.
happen, you know? Like
That's
that's
a
scary. That keeps me up at night because I think about that. I'm like, shit, man. Like, what? And also, what wouldn't these people do to like keep it quiet, right? Like, it's
yeah.
everything's on the line with free
Yeah.
energy, like everything.
Yeah, it's kind of like isn't that Arrival? Isn't that Arrival where they give the like the whatever like the 13 major powers 1/13th of the puzzle or something, and it
Yeah.
forces them to work together. Yeah, or it might be yeah, it's one or the other. Complete altruism or complete total fascism locked in. Yeah, I mean, and then if you were in power and you thought that that's what you needed to like not blow up mankind, you might look at that as like a necessary or a reasonable sacrifice.
Oh no, and
It's,
I think that's exactly what they think. I think that's not the only reason. I also think they're greedy,
I
right?
think they're
And they
also
want to
horrible
profit off
pieces
it as
of shit,
well.
but like
Yeah.
it, but
But that's
this
a
is where
big one, right? Like
it's
that's number one. Number two is like it's going to collapse all socioeconomic structures on our planet, right? Like we're talking
yeah,
about if you can pull energy out of an unlimited ocean, you can basically just conjure hydrogen out of the ocean and or out of the ocean of energy, and you might even be able to transmute elements. So like I mean, for people that are physicists or engineers, just look at this video. Look
yeah,
at how
this is
fast this
wild.
engine's going, and you're seeing the middle of it cooling down. And there's this cooling zone where the magnets are spinning as well. You can see this very clear cooling zone that's just black.
Whoa.
And this, if people that have been following me, that have been following my work on the MH370 videos,
This looks like
realize
some
that one of those is a drone video in thermal, and we're
uh
seeing black lines in front of the orbs, and we're seeing a big black blotch when the
at
plane disappears.
the
And you
event, yeah.
realize this is an endothermic event that we're seeing in those videos, just like this. And you can see the connection now to free energy. Like there's ways to use the same science to produce free energy, pulling the energy straight out of the ether from the sea of energy. That's the same thing as bending gravity, manipulating gravity. And if you go to such a degree where you create a singularity, like that's a black hole, but it's also potentially a wormhole. And the only difference between the two is that a wormhole doesn't have the amount of gravity that would rip you to shreds, doesn't have an event horizon. A wormhole is just a very, very temporary rip, like where all of a sudden at once, I'm going to pull all the energy out of a location. I'm going to break through some limit that's out there, break through the ceiling. And once I break through that, now you have this black hole or this wormhole, and then it closes up right away because what happens? All the energy collapses right back on the spot where you created the singularity. And it does so in a way that it doesn't cause an explosion. It doesn't cause a massive shock wave because it's happening on a dimension that we're not perceiving. It's not as simple as where all the stuff that we see around us right now. So yeah, this video is amazing. This is a testing technically of the MEC, which is I forget what it stands for, but there you go. There's the frost at the end. Let me show that one more
Do
time.
that again.
So you can see like it's so cold that there's actually frost
Dude.
on the middle of this. And so you look at it, you're like, okay, well,
I mean, devil's
entropy
advocate,
is
if you wanted to,
like, go ahead.
I was gonna say devil's advocate, if you wanted to fake that, you could maybe under it, you had like a super cooled. I mean, if you were just spamming the video, I don't know, under it, yeah, I don't know, take the coil from like a laboratory freezer. I mean, just as devil's advocate, but it looked like it was in like a showroom or something. So I don't
Yeah, I
think
mean,
it was.
everything in this world can be faked at this
Sure,
point, but
but
like
that's the
that's why
only
you
thing I
follow
can
the
think
science,
of.
right?
That's the only thing I can think of is be like, if I took this phone and was like, Ashton, look, it's sucking in energy, and like I zoomed out and it's in my freezer, you'd be like, fuck off, dude. Like, like that's the only thing I could think of. Because otherwise, no, that's why air conditioning is more energy intensive than heating, because heating, a byproduct of all processes, is heat. So it works well for heating. For air conditioning, you are cooling things down, and the process of cooling also is, aside from creating excess heat, because that's how you cool, just the very motion of anything causes heat, which is why it's so energy intensive. So that
Yeah,
makes
why are we
no
adding
sense.
energy to cool things down? It seems counterintuitive, right? Like the more energy you add, the more it should heat up. And you're like, well, I'm doing that to cool things down. It's kind of counter, it's like the exact opposite of what I would want to do. Instead, just pull the energy out of there and it should naturally cool down.
Yeah.
And that's why you see those cooling effects on free energy devices. And this is why it's so important. Like, you can't just show somebody, it's not enough anymore. This is why people ask, like, well, just show me. It doesn't matter because the moment I show you, you're going to immediately move the goalpost and say, well, they could just be hiding a battery or something,
Yeah,
which,
yeah.
it's a plausible to say
It's
that. I mean,
yeah.
but it doesn't mean that's what they're doing. And that's the thing is that instead, what's the answer? Just teach people. Teach people
Yeah.
how the physics actually works. It's testable, it's reproducible. And if you teach people, the moment you actually understand just the simple concept of this energy that's all out there, then you realize like all the rest of it, so of course this is all possible. There's no need to fake it because it's real. Like the science is
Yeah.
real. Um, and I think that's why I take that approach as opposed to everybody else that's out there. It's like, oh, I'm just going to tell stories and they tried to kill this person. Yes, of course they probably killed some people over this. You kidding me?
Of
Like
course.
we couldn't give people this technology, certainly not 1970s or whatever. We might not be able to give people this technology now.
Yeah.
I think the only reason why they don't kill people as much now is because we have much better forensic technology and people are always
It's
filming themselves
harder.
everywhere. So it's a lot harder to pull it off. Like, so instead they just like discredit you. They claim you're crazy. They'll be like, no, my expert said that's not possible. Here, inject yourself with 3 more shots for a cold virus. Like, like we
It's
don't think for ourselves anymore. We just like do whatever the authority tells us, no question whatsoever.
do you know
Maybe that's what
how
they
much
need. I don't know.
do you know how much of a headache it is fucking trying to blow Trump's head off in 2024? Can you imagine just them like I just imagine them like, I don't know. It's like their grandpas were the ones that did JFK. They're like, "You did what?" With cameras all around. We had one Zapruder film and we locked that down for a decade. You did it where? It's, well, people on TikTok are posting videos where they said, "Hey, look, shooter." You can just imagine like James Jesus Angleton, head of the CIA in this thing. You just imagine him like taking off his belt and be like, "I'm gonna whip you, stupid." You did what? You tried to shoot the president in 2024? Are you fucking hot? Like, it is kind of funny, but like, um,
Well, that's a good example though, because I mean, like they tried to downplay that and pretend like it wasn't even an
Y-
assassination attempt. But we're like, we've got like dozens of videos of this guy. People literally,
Under an
people are videoing
hour.
themselves going, dude, there's a guy up there with a
Yeah,
gun,
it
and they're
got
not even going to help.
it was like a
Like,
shitty SNL skit. It's like, well, some people are saying that there's a gunshot, and then like another video, it's like there's a guy with the gun. And it's like, well, that person's lying. And then it's like 10 minutes later, another video comes out where they're like pointing. They're like, look, just to the left of that tree, there's a guy crawling, and you're like, well, this is worse. And then finally, a sheriff's like, yeah, well, I walked up there and I saw a guy with a gun. You're like, Jesus Christ, like, well, like
it doesn't seem possible, but there's
no,
still people who like will deny that it even happened.
it's like a
You're like,
it's
are you
Three
kidding me, man?
Stooges. It's Mo, Larry, and Curly. It's like whoop 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 whoop. Like it's just like, but what I was gonna say is, man, just going down the rabbit hole is like you could absolutely marry this with like Antarctica conspiracies. Would be like, well, where's if you had to if you wanted to find out what else looks like this, it'd be like I don't know. I'm just saying a thermal image of Earth would really look like a black hole. That's
Okay,
where
are
you'd
you ready
hide
for my
it.
Antarctica my thing? So
That's where
that's
you'd
a
hide
perfect
it.
segue
Yeah.
because I've got a theory in Antarctica that I think is unique. And I watched this guy, Eric Hecker. He was on Sean Ryan's show, and he was talking about how he went to Antarctica with Raytheon. He's a contractor. He's a utilities guy. He's like,
Fuck
basically,
is
I have the key
Raytheon
to like,
doing in Antarctica? Sorry, keep going.
so he's like got the key to like every building there. And he goes on Antarctica and he's like, people need to understand that like these detectors they have are not just detectors, they can transmit energy as well. And I'm going, huh, this is kind of up my alley. It's on the Tesla side, scalar physics with Tom Bearden. And so I'm like, I got to talk to this guy. And he tells me all about these detectors out there. He tells me he thinks one of them is a faster than light communication device. You can see lasers, like these pictures out there. You can find these pictures of green lasers going into the sky.
Mm.
He's like, I saw that one night. He didn't know the picture was out there on the internet. And then they've got these globes that are like stuck in the ice that are like this huge array. They're about to make it 10 times bigger as well. And I'm like, okay, I can see this. And I'm wondering if there's like more going on. Like, this is not just a neutrino detector. Maybe this is like more than what's advertised.
Whoa.
And then he says, well, and this is his words, that there was one time where they had this issue with the helium-3 containment that he said that he was like, I want to look into what superfluid means because we were storing 450,000 gallons of superfluid helium-6 or 3. And I go, whoa, because I knew that that's a Bose-Einstein condensate, which is
It's
very
the fifth
similar to
state.
plasma.
It's
And
the
it
fifth
has
state, right?
very unique properties to it. And you keep it at this almost absolute zero. And the reason why it stays a liquid instead of becoming a solid is because of the 0 point energy. The 0 point energy, even at what we think of as absolute zero, can actually go lower. There's this energy out there that keeps it in liquid form. And what they use it for is in part to cool superconductors, which are also weird. So superconductors, going back to the beginning, have no electrical resistance whatsoever. So now remember our parametric oscillations, like with no resistance, this thing is instantly going to like massive amounts of energy. So I look at this and I go, wow, I wonder if they have some kind of gravity communication device. Remember, gravity is
Mhm.
just this, the oscillations. So what if they're using a high frequency gravitational detector slash transmitter into Antarctica? And it's basically like LIGO, which is the low frequency
Mhm.
gravitational detector that we use to detect gravitational waves publicly for the first time in 2015. What if we've
Yeah.
got something like that, but like to flip the thing before about, so people are probably now all black pilled. They're like, Fermi paradox, we're going to wipe ourselves out with black hole weapons. What if we turn, instead of using low frequency gravitational waves, we look for high frequency gravitational waves, ones that are potentially produced by civilizations like ourselves? And we look out there, what if the whole galaxy just lights up?
Yeah.
Where all of a sudden we're seeing these basically detections of possible communications, possible warp drives of actual craft flying around, and we're just seeing them everywhere
Just
now.
everywhere.
Where before we weren't seeing them because we weren't looking for them.
Well, I was just thinking of something else. Is well, in the same way that like the early missile detection satellite systems in like the '70s, like you look for the rocket plume, you look for the thermal plume because it's insanely bright, or like when helicopters would go looking for like weed farms, you'd look for the IR whatever return signature. So if you wanted to hide, the same way if you wanted to hide a missile, you'd fire it with the sun behind it, so you can't detect the thermals. if you were doing something like this, you'd want to hide it somewhere really cold so you wouldn't tell. Um, but also, what if it's the black hole thing, but it's not black built? What if that's actually the sign of energy? Because if we're talking like black, it sucks it in. It might be that black holes are no, those are the civilizations. They're just same way when you look down at like a city at night and it's just glowing, from space. This might just be that, but we have to change our frame of reference. It's like no, dark is good. So you look out and you see all the stars. That's the equivalent of looking at North Korea at night versus when you look at like South Korea and it's all lit up. That might be what the black holes are. So it's not black pilling at all. You go, there's a black hole, and it's like that's civilization. This
Yeah, you
is
use it
the
as a shield. You can
emanation.
protect yourself maybe too. Like you don't want anybody to see you.
Well, that might not even be intentional. That just might be a side effect of like, well, that's what it does, is it shields it and it looks like it's. I mean, what would be the perfect camouflage if you're trying to hide from other? You'd want to make it look thermally dead. You'd say
Yeah,
there's a black
100%.
hole, nothing's coming out. Well, it might be that that's just like, no, that's civilization using like over unity devices. And wouldn't it also kind of make sense that that's at the center of a galaxy? It'd be like the central capital where everything's, the same way. You'd say like, yeah, no, that's their DC. So at the center of every galaxy is a black hole. Yeah, every country has a capital.
Are you familiar with the Kardashev scale, which is the
Yeah,
scale?
yeah.
Yeah.
Yeah, no, that might be all those.
Yeah, we basically have to redo that scale in light
Yeah.
of this because that scale presumes that there's nothing out there to extract.
Yeah,
And they
no, it's
think,
all
oh,
you
well,
got
we're
a
gonna make these
Dyson
Dyson
spheres and
spheres
around.
around the
Yeah.
sun. It's like, dude, we don't need to
Uh,
do any of that shit. Like, we don't
yeah.
need the energy from the sun. We can just extract energy directly the same way the sun itself is extracting the energy. And if you look at it like that, you're like, okay, well, now we've got to redo this because
Yeah.
now you don't really go up the scale anymore. It's like you either don't understand it or you do.
You're on it.
And the moment
Yeah.
you understand it, things just get bananas. And this is where like small devices are not a threat. So you can, make a magnetic motor, use magnets to manipulate this free energy and then basically store it in some mechanism like with batteries and things like that. Because you're basically riling up using electromagnetic fields, you're riling that sea of energy up and then you can extract it. Now you can probably use parametric oscillation, which is probably one way to do it. I don't feel comfortable going into any more depth on that, but I'll just say like you can check into that, and I think that it seems like a logical path to follow. Plasmas though are, in my opinion, where the money's at because Salvatore Paez, Navy engineer, again Navy approved patents, has a magnetically confined plasma. So I used to be all about these tokamak reactors, which have already
Hmm.
shown coefficient of performance greater than one. I don't know how
Yeah.
people don't like
It was a
rationalize
couple of
it, but
years ago.
like,
They came out and they were like, we put in one and we got
yeah,
1.2 out.
they got 1.5, and
Oh,
that was
okay.
in 2022. And I'm
Yeah,
like,
that
people
should be
just
like the biggest news.
and people, I don't know, like people just blank it out. I'm like, are you listening to what they're saying? They're saying they got coefficient of performance greater than one. Like, where is that extra energy coming from? We're not even breaking bonds. We're fusing things together. So it should take more. Like, where is this energy coming from? And you realize this is the same as free energy. Like there is no distinction between using plasma to pull energy out or a magnetic motor. You're just using a different medium, a different operation for it. And they can be of different efficiencies. Now, the important part to understand about this, big misconception. People think in order to produce free energy, you can have no input. Like it just needs to literally just come from nowhere. But even with the plasma reactors, the tokamaks, they input energy. They just get more out than what they put in. And even with like a magnetic motor situation, you got to get it started for sure. And before it starts producing that energy, you have to think about logically how this works. So you don't need to have no net input, just like with the swing example, right? It's not about having no push at all. It's about pushing at the right resonance. And if you push at the right resonance, then you get a situation where you're getting more out than what you're getting in. And you realize we're not violating the first law of thermodynamics. The energy is not being created, it's just being accessed and it's all around us. And the second law of thermodynamics is you get around the second law, which is it's kind of a confusing second law. It basically just says that you can never have a system that's perfectly efficient. My closed system that I create here, you're always going to lose some energy due to
Mm.
heat. And because of that, it can never be 100% efficient. But this is the same problem as like with a windmill. If you look at a windmill with no wind, you would say, yeah, that can never produce energy. Doesn't make any sense. But once you add the wind in, your external factor, Now you have your external, you've opened your system up to the wind, and now you're getting energy out of it. And it doesn't have to be 100% efficient. Same idea as free energy in terms of from the ether, the over unity is you're pulling energy in from the 0 point fluctuations the same way you are with the wind. Only you get an added benefit. When you're pulling this energy out, you're actually cooling down your system as well. And your system can have an input. You just need to have more output than you have on your input. And it can actually lose energy due to heat too. That's fine. Doesn't matter because we have our extra input. As long as the sum of these, this one plus the output or whatever, as long as you're getting more energy out than you're putting in, as long as you're getting that, then you're good to go. Because then what you can do is you can just take your output and you can just plug it back into your input. And then you can set up your circuit in such a way where after you get it going, it's just going forever and producing excess energy. In fact, the problem then becomes, what do you do with all that excess energy? Because are you constantly having all your lights on? No, you only kind of want it sometimes. So you have to have it go feed a battery, right? Maybe like a Tesla wall battery or something like that. Okay, well, what happens when that gets full? Like I go to sleep and I'm not using any energy. So you need to have, and there's easy ways around this. Like you have it automatically turn off and then wind back up again. You either have to like, manage it or have a situation where it doesn't blow itself out, because otherwise what you can have it do is it's going to short circuit if it's just pulling too much energy. And now this is the part where like you realize, okay, this is more complicated than just producing it. Because if you're using it off the grid, then you have to have a system to manage the energy so it doesn't short circuit. If you're using it on the grid, then what are you going to do when the energy company comes to you and says, why are you not using any energy? Like you've been here, like what's going on here? Like you were using a whole ton before and now you're using none. Like they're going to figure it out and then it's just going to get really awkward. So the situation is a lot more volatile than what people just think with respect to, produce it. And then the also question is, well, how much does it cost to make a device and how much is it extracting? Like how powerful is it going to be? Because even if you have, these types of devices, it's very highly skilled labor. It's not just any random person. Most electricians and electrical engineers don't even know where energy comes from. So you need somebody who actually understands the concepts to build it for you. And like if you're using permanent magnets for like a magnetic motor, that's probably your cheapest option. They're still really expensive. Like the powerful neodymium magnets, they're actually really expensive. And they don't run out. But all a magnet is too is an alignment of the spins of the electrons. So if you were to like look at a magnet, all you're going to see is all the spins are like perfectly aligned in the electrons. That's why the magnetic field is so powerful. And so now you start to see everything as just electricity, like the electrons moving, the electrons being aligned to create a powerful magnet. And it makes sense then that very powerfully aligned electrons are going to manipulate the 0 point field. And if you can manipulate, then it's just a matter of, okay, well, we've made a splash in the ocean, but we need to collect all the water as well, because otherwise it's going to dissipate back into the environment. And that's where potentially like your capacitor comes into play, maybe ultra capacitor capability as well, so that it's like something that can just hold a huge amount of energy. And you don't even necessarily need one. I mean, if you just want to run a bunch of stuff, you could do that without having the capacitor, but that would certainly help. So, yeah, I think that the two ways that are the most likely ways of producing it are with magnetic motors and then plasma, confined plasma, not in a tokamak, like just magnetically confined, like in a orb, a sphere of energy. And then what I think will happen in the future is that we'll miniaturize this down like we have with everything else, because when you realize that it's really just about an asymmetry, more charge here than here, then you look at, well, how can I make like a tiny circuit, like smaller than my nail here? And all I want to do is create an asymmetry. And then I'm going to take those circuits and I'm going to build like a microchip, put it on a wafer or whatever, and make a thing out of it. Like that's what we do nowadays with everything. Like when we built the flight managed systems for airplanes for autopilot, we took this giant gyroscope that was like as big as your closet, and now it's scaled down to being like a tiny microchip that's like this size, and it can do all the same stuff. So you realize like when we can do that, and people are gonna say, well, how would you do that? That's impossible. No, actually, this guy, Garrett Model out of University of Colorado, he's like professor emeritus or whatever. He has been looking in Casimir cavities, which takes the same idea of the Casimir effect, like these plates coming together. And instead he just like makes like this gap in there. And this gap alone just creates an asymmetry between like a conductor, an insulator, and another conductor. And if you can engineer it so that you can create this asymmetry, then scale it up. Now you're in a situation where you're creating a battery that just by existing is pulling energy out of the ether and never runs out. So I think that that's got a lot of possibility. I actually emailed Garrett Model and I said, "Hey, do you have any other information about like any updates on this?" I mean, he's been working on it like 20 years. I watched some of his videos, and basically he said he had a lot of people that were reaching out, and he couldn't respond too much, which I respected. I wasn't really
Sure.
looking for a lot, but yeah. So just to give you an idea of like where this can go and how quickly it can go there, I think it's just a matter of economics and commercialization at this point in terms of how do you scale it down to a degree where it's now cost beneficial for homes. You know, I've got a $500 a month utility bill. So add that up, $6,000 a year. And let's say the device lasts for 10 years. So
60.
now I would need it to be under $60,000 in order to get a profit off of it as an end user, right? Well, I don't know if we're actually at that point. You know, I think that this is the part where, um, you know, we have to figure out like, okay, when it gets low enough for some people, and it's different everywhere in the world and every part of the country as well, where it's cheap enough, then I think it's going to take off. The industry is going to go through the roof, right? And then as innovation comes into play, things get cheaper and cheaper and cheaper, smaller and smaller and smaller. And once we hit that inflection point, like it's going to be similar to Tesla cars, where it's like electric cars and stuff like that, but even more impactful. Like it's like we still use gas powered cars a lot right now because the price difference, while it's significant, it's not backbreaking. But like with this, it's going to happen so rapidly. I think that like all old forms of energy generation are within like 10 years going to become completely obsolete.
Yeah. Yeah, and it might also be that not every home needs one. It could just be the current system, which is fraught with problems, but just having a centralized, like I don't have a power plant in my apartment. I'm connected to the grid. You might just have something where it's like maybe it doesn't need to be 60K. Maybe you
And
need to make something
non-centralized
that's
power, right?
yeah, maybe you need to make something that's well, I get yeah, and get you don't want centralization, but even if it was just purely from the profit motive, you'd be like, yeah, it's can't get it below 60K for each home, but what it costs for a town or a city. And then you can do it. And then you'd have specialized people that much like you run a power plant or something, which then comes back to all the same problems of centralization and, you know, energy being used as a currency like the petrodollar and really a rule mechanism. But
So this is let me real quick.
yeah, yeah,
That's
yeah.
funny because um so I started a company that's related to magnetic motor use, and what I'll say is that there are people that are interested in some of those concepts that you brought up, like why it doesn't necessarily have to be like one individual household. Like you don't need
Yeah.
one per household. Like you can build a little town, your town can be run off of it. And you realize not everything. A lot of people live in the city, but there's a lot of rural areas
Yeah.
out there too, where like this starts to make sense. It can protect you from natural disasters as well. You're not linked to the power grid anymore. You're not dependent upon it. So for me as a libertarian, I love that aspect of it in terms of freeing us from those structures that are out
Hmm.
there. Um, so yeah, I think that's huge. And then actually no, go ahead. That's I forgot my other thought.
No, that's all I was gonna say is yeah, no, I mean
But this is why I like talking to you because you see it from the logical perspective, right? Like anytime I bring it up, like throughout this conversation, you've already brought up like three different aspects of it, like the Fermi paradox aspect of it, the cover up aspect, like why you would keep it secret, like we did with the Manhattan Project, why people wouldn't believe it unless we've seen it, like when we dropped the A bomb and we realized, oh, E does equal MC squared. And then also just now with like how you commercialize it, like the actual limitations from the commercialization of it.
yeah.
So, and it can free us from polluting the planet too for the people that are all about, keeping us green. Like this is better green energy than any other source, even solar, even wind that's
Yeah.
out there.
This is true
It's just
green.
disruptive and is dangerous due to what we talked about with the implications of what you can do with it. So, and for people that would say, okay, well, show me, I want to see it, blah, blah, blah. There are videos that are out there. The reason why there's so many videos about free energy that are out there, some of them are real. The problem is, how do you tell the difference? Well, hopefully today, now based on our conversation, you've learned how to tell the difference. You know what to look for, not just coefficient of performance greater than 1, something that shows you the meters. You also want to see a cooling effect. There should be a cooling effect if the effect of the pulling the energy is powerful enough. If it's not, then you potentially going to see only minor cooling, so that's not a deal breaker. And then ones that are also showing that there's a mass reduction or a mass increase effect, depending on the, like with that magnetic motor that was spinning around, that's John Searle's device. It depends on which way it's oriented. So depending on which way you spin it, it's either going to increase weight or it's going to reduce weight. Like if I were to flip it over, it's going to increase weight. If you flip it over, it's going to reduce weight. So there should be an effect like that. The Kepler MEC has all of these as well. And that's because it's also manipulating gravity when it does this. And then, so some other people, John Searle, John Bedini, he was definitely legit. Tom Bearden, like I mentioned before, although his device, he's got the patents that are out there, but his patents don't have all like the engineering, like circuitry and stuff like that you need. And John Hutchinson, I think, probably was on it and
Yeah.
probably had it figured out. Stanley Meyer, the water powered car guy. All these people, by the way, discredited. All of them died in
Tom
from, let's say,
Ogle,
just
another
unfortunate
batter.
situations.
He's
Yeah,
found dead.
suspicious and unfortunate situation. Well, John, I used to think that Stanley Meyer was kind of like that was nonsense, that you were like running your power water or car on water. But what he was doing is he was creating a negative entropy situation with the water. And what it's doing then is the bonds of the hydrogen and oxygen are just separating. And it's not like you have to violently rip them apart. It's just the moment you create, you pull the energy out of that area, the bonds just fall apart. And so what happens is the water starts to just give off oxygen and hydrogen gas. And then you pump that gas to a different area, you mix it with atmosphere, and you use it as fuel for your combustion engine. And potentially when the bonds break as well, they might be giving off energy when they do that too. So like that, you look at that and you go, wow, like this is, he had figured out free energy, but a different concept for it, using the same fundamental programming language, the fundamental basis for our reality and what our reality is based on in terms of the energy. It's like you imagine the energy get more and more complicated. Okay, I'm just going to take it down one level instead of trying to like rip it apart or whatever. And once you take it
Yeah.
down one level, now it just goes back to its previous form, the form that it was in right before that. So Stanley Meyer probably had it figured out. And if you're interested in that, the basic absolute proof that this is all real is sonoluminescence.
Mm-hmm.
So with sonoluminescence, they have this water and they shoot sound waves
Yeah.
at it. And again, with a specific frequency where they're hitting each other, and you get a star in a jar, a miniature star. How is that possible? In fact, how is the energy that it's giving off not like destroying the glass that's containing the water? How is it not vaporizing the water all around it
Yeah.
as well? And nobody has any answers to this. But when you look at the universe the way that I've explained it on this podcast, you realize this is the answer. That's the proof that we can create cold fusion. It doesn't require this huge star to pull off. Like we can do it at small scales. And we can do it in water, like with Stanley Meyer. He was probably doing basically that. And we can do it as well in plasma. In fact, plasma, in my opinion, is probably the best medium to pull it off in. And it probably has the most powerful effects.
Yeah. And it's, I mean, like a random forest fire is that's like proof of concept versus, controlled fire, like an internal combustion engine or something, or, water boiling off in the desert. That's like proof of concept versus like an actual high efficiency engine or generator. Yeah, it makes sense that like the star is sort of that's like the shitty natural version. It's just showing proof of concept. Like, no, it can be better, right? It can be better. But yeah, no, I mean, it is the ultimate mode of power. I don't mean literal I mean human power, corrupt power is, you know, the monopoly of energy. But it might just be something that this is, history is wrought with just kind of these periods of gatekeepers being destroyed, be it from saying the mass in Latin to whatever your language is, or saying that you have to talk to a priest to talk to God versus saying like, hey, just read the Bible. The Wikipedia I was reading about it's like CIA, operations in high school. But my grandparents in high school, you get the news through the radio, and Uncle Sam can do no wrong. History is just a series of many things. One of the things it is just the continual, sometimes it's a century or 5 centuries apart, is the breaking down of gatekeepers. Just more and more and more about, the knowledge is free for everyone. So this might just be another step of kind of the gatekeepers breaking. Like we might look back in 500 years and be like, that was so weird. Yeah, there used to be like an elite class of people who understood physics, but they wouldn't let everyone else know. The same way we look back at like, yeah, a couple kings got to live in the castle, but everyone else had to go toil in the field. It's like this could just be another sort of step down from centralized power. Um, yeah. But yeah, Ashton, I said we wrap this one up. I don't even know how long we've been going for. How we've been going for an hour and a half.
No, it's good. That was a
Yeah,
good
no, that
conversation
was
over free
fucking great,
energy.
man. That was
I,
fun. Thank you so much for coming on.
Yeah, and thanks for your audience for listening. I think that it's one of those things where you have to bring more awareness to it, and you really have to like teach people how to break down the brainwashing of what we've been taught. A lot of people just think like the laws of
Yeah, they
thermodynamics
don't.
say
Yeah.
that free energy is not possible, but it's like, okay, well, tell me what your understanding of physics is. Like, I want to dig into that more. And one thing I've learned is really sad related to academia and gatekeepers is that they really are gatekeeping this information. Like a lot of people literally will just say like, yes, 0 point energy exists, but it's just like too small for us to benefit from. And you're like, who told you that? Like what scientific proof is
Safe and
there of that?
effective. Trump is a Nazi. What are your own thoughts? What are your not what you were told? Tell me
There's
your own thoughts.
Here's the craziest thing too. There's people out there where like they've actually developed experiments where they are seeing the underlying framework that we're describing here and effects that they can't explain classically, and they still are just like, well, it's I'm not cheating at all, but it's magic. You're like, it's not magic. Like you're obviously just you have to go to some of your foundational core beliefs and be like, are these really
Are these
correct, or
correct?
did I mess up? And then maybe we have to shift somewhere here. And it's as honestly as simple as 100 years ago moving away from this idea of the ether. Like we believed strongly that the ether was this energy source that's out there, and that electromagnetic waves are using that as a medium. And it's like, there you go. We moved away from it because we were like, no, we like general relativity more, and we don't like the ether. And it's like if we just go back to that, we can just answer all the questions that we're struggling with. We can explain why, like Professor David Greer at NYU has got a tractor beam laser and he doesn't even know how it works. I'm like, dude, like, do you think maybe you just created a negative energy laser? Like, were you using squeezed light? Because if so, like you're dipping in to this energy level
Mhm.
here and you're creating a counter force to gravity. Like, there you go. There's your answer. But some of them, like you tell them that, and I literally told him that in an email. They just don't get it. They don't get it because the brainwashing is so powerful in all aspects of our life. So I appreciate everybody listening, and hopefully, we woke up a few more people.
Yeah, and we'll do another one. Thanks for coming on, dude. As always, I appreciate it. I enjoy the brainstorming. Yeah, I don't I, why it doesn't have to be blackpilling. It could be that those are all just points of civilization. So yeah, don't be blackpilled. Blackpilling is gay. Don't do that. But yeah, Ashton, till next time. Thank you so much for coming on here, guys. Please go in the description. Please go follow him on Twitter. I have whatever. I don't know if you're YouTube or subs. I have all your links in there. Go follow Ashton in the description. Don't make me look bad. Dude, thank you so much for your time. You have a wonderful day. And till next time. Appreciate
Thanks,
it.
Tommy.
Guys, take care.